Namaste friends, welcome to Rhchemistry. In today's Neet-Booster 2020, number 4, chemical bonding chapter I am going to discuss. Already I have solved some more questions in the COMEDK part and also in the KCET part. You can go through those videos also. Definitely it will help you in NEET exam also. And in the next video in JEE also I am going to explain the same chapter. And if you have not downloaded the synopsis part, so you can go to description. I have given the link so that you can download and you can use that. So handwritten, beautiful, colorful notes are there here. So first question. Which of the following diatomic molecule species has only pi bonds according to molecular orbital theory? And remember, chemical bonding means two important parts, that is VBT and MOT, molecular orbital theory. And maximum question you can see on these parts. Maximum question you can see on these part. Remember, very important part. So in this particular case, which of the following has only pi bonds they are asking. So it is depending on, remember, the molecular orbital theory. Write the configuration. So total electrons I will write it first. So total electrons, remember. So in this case it is 8 electron and here it is 16 electron. Here it is 14 electron and here it is 12 electron. So remember, for 16 electron system, one configuration, 14 electron and less than that, one configuration I will tell you. BE2, option A if you see, so sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Which means only pi bonds according to the molecular orbital theory means the last orbital should be pi. That you have to remember. So hence, this will not the answer. Last orbital should have the electron in the pi orbital. That is very important here. Then B, if you take oxygen molecule, 16 electron system, sigma 1s2, so sigma star 1s2, so sigma 2s2, sigma star 2s2, then sigma 2pz2 because it is 16 electron system, sigma 2pz2, then pi 2px2, pi 2py2, then pi star 2px1 and pi star 2py1. Which means last electron present in pi star and pi star, hence pi bond is not possible because these will not support the bond formation. So remember, so pi star 2px, pi star 2py. So here one very important point is, they are not asking only pi bonds, but oxygen if you see, here there is a sigma bond and pi bond. We know that. So oxygen is having double bond, one sigma and one pi, but they are asking both are pi. So hence remember, in this particular case, B is not the answer. Like that, C is also not the answer. In shortcut I will tell you, nitrogen means N triple bond N. N triple bond N means we know that 1 sigma and 2 pi. Definitely only pi bond they are asking, that is not possible. But directly I will write for, because of that reason, C2. C2 remember, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, and remember pi 2px, pi 2py. Right? So pi 2p, here 8 electrons are over. So 9, 10, 11, 12. Only pi bond having the electron. Hence remember, only pi bonds are present. So answer for this question is D. And remember, it is a hypothetical molecule. Hypothetical molecule according to molecular orbital theory, which is having only pi bonds. Like this you have to see. Then which one of the following have highest bond order? Highest bond order, remember one very important point I will tell you. So isoelectronic, this is the hint, remember, isoelectronic species have same bond order. Same bond order. Remember that point. Why I am telling this is, most of the time what happens, whenever we will tell O2, we know that O double bond O, right? Which means 2 double bond. So bond order is equal to 2. If it is N2, remember, bond order is equal to 3 because we know that triple bond is present between nitrogen. So hence I am telling, so that is a shortcut. Now you can say highest bond order means generally 3 is the highest bond order. Correct? In which case 14 electron system is there, immediately you can tell that as answer. See, NO 7 plus 8. So 15 electron system, 2.5 bond order will get. So C and N, 7 plus 6 plus 7, 13 minus means plus 1. So 14 electron system, that is B. Bond order is 3. That is a shortcut in this particular case. Remember that. Then Among the following, which one is the wrong statement? Which one is the wrong statement? Remember, very simple. PH5 and BiCl5 does not exist. Yes or no? See, phosphorus, H5, definitely it does not exist. Remember that point. Hydride of the phosphorus is maximum pH3. pH3. It is not stable. It does not exist. It is not meaning. See, NH5 does not exist because of non-availability of d orbital. But it is not. That is the reason. But that is not stable. BiCl5 is also not exist. Remember. So bismuth case, BiF5 exists. BiF5 exists because of bismuth plus 5 oxidation state is not stable due to inert pair effect. So, does not exist is the correct statement. P-pi, D-pi bonds are present in SO2. Definitely it is possible because sulfur is having d orbital, oxygen is having p orbital. So, P-pi, D-pi bond is possible. Then, SCF4, CH4 have same shape. Then if you see SCF4 and CH4 is having tetrahedral. Correct? SCF4 we will see. SCF4. First we will see the hybridization. See one thing, if one center surrounded by 4, it is not always tetrahedral. It is depending on the hybridization. If it is sp3 tetrahedral, we can say. Now hybridization calculation, once again I will tell you the formula. So H is equal to half into, so valence electron plus monovalent atoms minus cationic charge plus anionic charge. Very, very helpful this formula. Remember that. Now you can see for Se, selenium comes under oxygen family. So valence electrons are, remember, 6 in that case. Plus F4 is 4. So here it is not their charge. So 10 by 2. So that H is equal to 5. 5 means, remember, hybridization is sp3d. sp3d with 4 surrounding. sp3d means how many surrounding? 1 plus 3 plus 1. 5 surrounding, trigonal bipyramidal shape. But 1 it is there. 1 it is there means, remember, it is a very famous one. So seesaw shape. So it is a seesaw shape, we will call it as. Remember, it is not tetrahedral. So incorrect statement is C. I3 has bent geometry is correct. See, I3 plus, see that I3 plus hybridization. So here it is just like I surrounded by 2I. Central iodine half into hybridization. So central iodine 7. Plus surrounding iodine 2 are 2, so 7 plus 2 and plus 1 is there, so minus 1 because anionic cationic charge minus, so it will become 8 by 2 means 4 means sp3 with 2 surrounding. Definitely it is just like a water molecule, so the shape of this molecule is bent geometry, it is correct. So incorrect statement is C. In which of the following pairs both the species are not isostructural? They are asking isostructural, same structure, for which one it is not correct. Always one thing you remember, diamond and SiC, we will call it as carborundum. What is this? Carborundum. Both are having same structure, that is diamond 3-dimensional structure. Remember that. Now, NS3PS3 we know that because NS3PS3 what happens, N and P comes under the same family, both are hydrides having the structure like this pyramidal shape. So hybridization also it remains same. Now see, you can say XCF4 XeO4. Now see the hybridization, XeO4 half into Xe is 8 valence electrons. So plus 4 is surrounding, no charge. So 8 plus 4, 12 by 2 means 6 is equal to sp3d2. Right? So now XeO4 you can see, XeO4, Xe is 8 plus 0 because oxygen is divalent divided by 2. So that 4 is equal to sp3. Then definitely both will never have a same shape. Hence answer should be isostructural. Answer is C. SiCl4, PCl4 same structure. So PCl4 plus, SiCl4 and PCl4 plus both are having tetrahedral structure in this particular case. Hence remember answer for this question is C. Fifth one. Which one of the following compounds show presence of intramolecular hydrogen bond? See, very simple question, something you have to think about. Intramolecular means between two molecules. H2O2 never form intramolecular. So intramolecular, one example I will give. So if you take orthonitrophenol, hydrogen and oxygen, intramolecular it is. Not is intra. Inter means between. See, H2O2 is having between. HCN is also between, because common sense is that this type of structure is required for that. Correct? Concentrated acetic acid is also between, inter. But cellulose structure, remember, you know that cellulose is having beta D glucose units. So C1, C4, C1, C6 linkage is present. Definitely in that case, the intramolecular hydrogen bonding is possible. So the answer for this question is C. Common sense also it is used. So H2O2, HCN, acetic acid is not having that complex structure like this, but this is having, and like cellulose is having. So answer is C. Which of the following molecule has maximum dipole moment? See, dipole moment. So structure you can see first, C double bond O. So mu is equal to 0 here, because symmetrical structure. CH4 is tetrahedral. Remember, tetrahedral also dipole moment is 0, you will tell. So mu is equal to 0. But NH3 and NF3 is having dipole moment. NH3 is like this. So remember, and NF3 is like this. NF3 is like this. Like this. Lone pair of electron is here. Now one thing you remember, NH3 has more dipole moment than NF3. Answer is C. Why that I will tell you. In case of the N, what happens is, so generally what we will do it like this. Remember, in this particular case, so which is electronegative? Nitrogen. Hence we will draw the structure like this. Remember, so arrow mark is towards that vector quantity it is. So this bond dipole also will show it like this. But NF3, what happens? F is more electronegative, hence it is reverse. Remember, reverse like this, and this is like this only. Now here what happens? This bond dipole and this bond dipole get cancelled, but here all 4 bond dipoles are in the same direction. Hence remember, in such case same direction is there. It will add to this dipole moment. Hence it will have more and it will have less dipole moment, that is NF3. NH3 is having more dipole moment. Answer is C. Remember this point. Whenever NH3, NF3 comes, NH3 is having more dipole moment. Fix this point in your mind. Then HCF2 is isostructural with. See, HCF2 isostructural with, one small hint is that surrounded by 2 means answer should also be surrounded by 2. Hence this will never be the answer. First you can remove it out. Correct? So now you can say this is BaCl to ionic compound. Ionic compound, hence it is not having any structure. So hence remember you can leave it. Then tellurium and this I. So now you can see hybridization of HCF2. HCF2 hybridization is, remember, HCF2, H is equal to, Xc is 8, half into Xc is 8 valence electron plus 2. F2 plus 2 divided by 2 means there is no charge. So 5, 10 by 2, 5 means sp3d. Sp3d. Correct? Now if the hybridization is sp3d here or sp3d here, definitely we will get the answer. Now you can see tellurium. TEF2. Tellurium is also, remember, valence, the halogen family. Correct? Fluorine, chlorine, bromine, iodine. So this tellurium. Tellurium comes under oxygen family. Oxygen family. So oxygen, sulfur, selenium, tellurium. So valence electrons are 6. Remember, valence electrons are 6 here. So in this particular case, TEF2 half into TE is 6 plus 2. So 8 divided by 2 means 4. Definitely it is not hybridization, same. ICL2 you can see only one option left. Definitely it should be the answer. ICL2 you can say half into I is 7 plus Cl is 2 because monovalent. Minus is there means plus 1. So 10 divided by 2 means definitely sp3d. Answer should be same. This is and this is. Both are HCF2 and ICL2. Both are having what? Linear structure. So like this you can solve this. Then which one of the following pairs is isostructural? Isostructural means here what they are asking, same shape and hybridization also they are asking. Same shape and hybridization. Fine. Now we will see. Now BCl3, BrCl3. See BCl3 famous one, remember, sp2 hybridization. Correct? So BrCl3 will calculate half into BrCl3, half into Br is 7 plus Cl3 is 3. So 10 by 2 is equal to 5 is equal to sp3d. Definitely it is not the answer. Right? Now we will see NH3. NH3, sp3, famous sp3 hybridization. Correct? So NO3 minus you calculate. Half into N means 5. 5 plus it is 3 means divalent, it is oxygen. You cannot see that divalent. So minus means plus 1. Divided by 2 means 6. So it is sp2. Correct? So divided by 2 means it is 3. 3 sp2. Sp2 means it is also not the answer because hybridization also same. NF3 BF3. NF3 and NS3 both are same because surrounded by H and F monovalent only. So it is sp3 only, not necessary to C. And BF3 we know that it is sp2. So it is also not necessary to C. Then BF4, it should be the answer now. Now you can say BF4 minus. B is 3 valence electron. Because boron, 1s2, 2s2, 2p1. 3 valence electron. So half into 3 plus 4 minus 1. Minus 1 because, sorry, plus 1. Plus 1 because there is a charge, remember. Right? So 4 plus 3, 7 plus 1, 8 by 2 is equal to 4 is equal to sp3. And NH4 plus, we also know that NH4 half into N is 5 plus 4. Minus 1 because plus 1 charge is there, minus 1. So 5 plus 4, 9 minus 1, 8. So 4 is equal to sp3. So answer for this question should be B. Then, during change of O2 to O2 minus, the electron adds to which one of the following orbital? O2 to O2 minus. O2 to O2 minus means 1 electron extra. Correct? So this you have to know. Now configuration you can say already we have written sigma 1s2, sigma star 1s2, sigma 2s, sigma star 2s, sigma 2p2, pi 2px2, pi 2py2, pi star 2px and pi star 2py1. So 1 electron we have to add. 1 electron where you will add? You will add it to this particular orbital to make it as 2. Correct? I will not write that here. So 2 you have to write it here. So 2 means pi star 2px orbital you have to add. Pi star orbital is the answer. Pi star orbital is the answer. So that is the 9th question. And the 10th question, last question in this case, the correct order in which the OO bond length increases in the following. OO bond length increases in the following. So in this particular case, what we know that we have to say. See, we know that O2, H2O2, O3 is given, correct? O2 is like this, O double bond. H2O2 is like this, HOOH, right? So this is open book like structure. Then O3 is like this, O double bond or single bond. Now, this is common, you have to know. So now, this is bond order is 2, correct? Bond order is 2, right? Here bond order is 1 because there is no resonance here. Bond order is equal to 1. So bond order is equal to 2, bond order is equal to 1. But here there is a resonance. Here there is a resonance means, so this can be written like this, remember. Oxygen, 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 and like this should be written. Correct? When it is written like this, remember, definitely we can say bond order is between 1 and 2. You can say bond order is between 1 and 2 because it is having the resonance, partial double bond character also it is there. Now, bond order if it is more, definitely bond length is less. Remember, bond order and bond length inversely proportional. Correct? So hence bond order is more, bond length is less. In which case O2 less. Right? 2 options left. Then it comes 1 and 2, between 1 and 2. So O3 then H2O2. So answer for this question should be D. So these are the 10 questions which I have solved. I hope you will get some help from this particular session. So definitely if you like this video, so comment if you have any doubts, like the video, share the video to your friends and subscribe to my channel if you are not subscribed. Thank you. Have a nice day.